This is the third of 7 short presentations or videos on the index laws and index notation. So this is the 4th and 5th index laws, and they're related to each other. Some textbooks refer to them as the same law, so we'll look at that as we go as well. So here's our learning goal. What we're hoping to get out of this is that we're able to apply these new index laws to allow us to simplify and solve problems. So the 4th index law is called the power law. Basically, it lets you raise an indicial expression. That just means something with an index to it. And what we do there is multiply the indices. So here's an example. You may have seen this before. A is our base, M is our power. We put the whole thing in brackets, and the whole expression there is put to the power of n. And the law says if we have the power placed to another power, we multiply those indexes. So it's a to the m times n, or a mn. And here's an example of why this works. So there's 2 to the power of 4, that's our internal expression. And we're putting that to the cubed or third power. So what this means is 2 to the power of 4 multiplied by 2 to the power of 4 multiplied by 2 to the power of 4. That's 3 times. That's what that cube there means. We could expand that further, but from our knowledge of the first index law, we know that when you multiply bases with the same base, you add those indexes. So we add the 4 to the 4 to the 4, which is the same as 3 groups of 12, 3 groups of 4, which equals 12. So 4 times 3 is 12, and that's why the index law works. So let's look at an example to get us started. We're going to simplify this expression. It's a numeric one, 7 to the power of 4, all to the power of 8. According to our 4th index law, we multiply those two indices together, 4 times 8, and we get 7 to the power of 32. You could quite quickly check your answer there by actually working that out on your calculator and then putting that answer to the power of 8. The 5th index law lets us build on that 4th law. And like I said, some textbooks refer to this as the same law. What it basically says is that where we have multiple items inside a bracket to a power, each item in that bracket has to be placed to the power, which becomes very important when we have coefficients and variable and pronumerals, so numeric values and algebraic values inside the bracket there. So we split that bracket up and place each element to the power of m in this case. We can also do that with other powers. So in this case, a multiplied by b to the power of n is in brackets, so b is an indicial expression as well. And we place a to the power outside the brackets, a at the m, and b to the n is our term in there. We place it to the power of m. And then according to our 4th law, our power law, we split that up and get m times n there for the base of b. So let's look at the division version. So this law applies for division as well. Anything inside the bracket has to be placed to the index outside the bracket. So that's how we remove that bracket there. So here's the example of the rule. A divided by b is all in brackets, so it's all to the power of m. So the numerator is placed to the power of m, that external power, and the denominator is also placed to the power of m. Similarly to what we did before, we can also expand using the 4th law for powers inside that bracket. So you'll see here that b to the power of n is all placed to the power of m, meaning the base there is b to the power of m times n according to the 4th law. And you'll see we've split out the numerator and done the same thing. So here's some examples. So in this case we've got 3 items in this expression. We've got a coefficient of 3, a base of a, and a base of b. So we need to split that cube power to each of those items or elements. So here we go. 3 is placed to the power of 3. The a squared is placed to the power of 3. So that's in brackets. So we're going to use the 4th law there to split that up further. And then b to the 5 is placed to the power of 3. So 3 cubed we know is 27. 3 times 3 times 3. This one here, because it's the 4th law, power to a power, we multiply those, 2 times 3, and similarly with the b, 5 times 3. So 27 comes down from there, a squared to the power of 3, 2 times 3, b power of 5 to the power of 3, 5 times 3. So our final answer is 27, a to the power of 6, b to the power of 15. Here's another example, and I've color-coded the indexes before we start in this case. So both of these expressions have different powers. They both have two elements to them, 2b to the power of 5 and 5b to the power of 8. So we need to split up this bracket and put each element, the 2 and the b to the 5 to the power of 2. We'll do the same over here, 5 to the power of 3, b to the 8 to the power of 3. And that looks like this. 2 squared, b to the 5 squared, 5 cubed, b to the 8 cubed. So we're going to multiply the 5 and the 2 here using the fourth index law, and similarly over here multiply the b, the base b, 8 times 3 to expand that bracket. So we get 2 squared is 4. This becomes 5 times 2 for our new index. 5 cubed is 125. And we multiply the 8 and 3 here. So our final answer, 4 times 125 times b squared, b to 10, sorry, 5 times 2 is 10. 8 times 3 is 24. And I've grouped the coefficients of the numeric values at the front there. So we've got one more step there to do. We've got like base here. For us to simplify that further, we use the first index law. So 4 times 125 is 500. And the index law that we're talking about, the first index law, add the indices when you multiply bases that are identical. So 10 plus 24 is b to the power of 34. So that's putting it all together. So here's another example. This one's division. This time we've got a mixture. So we've got two expressions on the numerator, or two elements, and one value on the denominator. So that's a to the power of 5 and d squared. So we need to place all three of those to the power of 3. So there's our first step. 2 cubed multiplied by a to the 5th cubed divided by d squared all cubed. Now we apply the fourth index law to simplify these two expressions. So we get 8 times a, 5 times 3 because it's power to the power, and on the denominator 2 times 3 is our new power there. Simplifying that, we get 8 a to the 15 all divided by d6. We can't simplify that any further because the bases are not identical. So this is showing you how we can use the fourth and fifth index laws, that is powers to powers, to simplify problems.